I'm David Pinsoff,
I'm David Pietrzewski.
and this is Evolutionary Psychology, the podcast, actual evolutionary psychology.
By actual evolutionary psychologists. Wow, that was
Perfect.
worthy of an Oscar. Okay. David, today's guest is Tadeg Quillien, and he studies really complicated things that are abstract and difficult to grasp from an adaptationist perspective.
Well, yeah, you make it sound really exciting and appealing for the listener.
Well, I honestly, this is if you feel like you want a mental Rubik's cube, this is the episode for you.
This is a mentally challenging episode for sure. It certainly expanded both of our minds. So yeah, maybe if you're sleepy, this isn't the best time to dive into this meaty
I
podcast.
did,
But
I did, I did rant about what a domain is, though. So
yeah,
yeah,
we had some good rants in there about simplicity and domain specificity and what it means to be computational. No, this one, if you're alert, you got a cup of coffee with you, and you think you can tackle this, this is a really fascinating, insightful, mind expanding episode about the nature of causality.
yeah.
Uh, which touches on literally everything the mind does, which is a point we get to in the episode. We could not do anything if we had no understanding of causality. Uh, and Tadeg just has a really elegant, insightful way of thinking about this complex topic. And I found a lot of value and learned a lot from talking to Tadeg.
Yeah, it's a really cool example of cool work at the cutting edge of computational modeling and sort of philosophy of causation. Um, and I think it's a challenge. You should take this as a challenge to grapple with these issues. These are chewy issues to deal with.
Absolutely, very chewy, very crunchy, very meaty. I'm just going to run through the food metaphors.
uh, this is great. But yeah, without further ado, here is Tadek and David and I talking about all things easy like causality.
Enjoy.
Tadek, tell us about where you are and how long you've been there.
I'm in Scotland. I'm at the University of Edinburgh, and it's been about 5 years now.
There's like a storied history of Edinburgh and computer science, and yeah, is that true?
So I think the first center for cognitive science, maybe in the world, was in Edinburgh. Um, so we had like people like Nick Chater were here,
Hmm.
people like Jeff Hinton, Peter Dayan, um,
Why?
and then
Why?
and then they chose to dissolve the center for some reason.
Hmm. Why Edinburgh? I mean, not to be US centric about it or continental centric about it, but like why Edinburgh?
Um, how do you mean? Why such
Yeah,
a
what is
yeah?
the
I mean,
why there? Yeah.
the answer I like is that maybe it's a city that has a long intellectual history, and we have um, people like David Hume
Yeah, I was
that
gonna
were
say
here.
Dave. I was gonna do a
Yeah, yes.
David Hume joke actually.
So I like to think that that is where the cognitive science energy is coming from.
Yeah, David
Hmm.
Hume. Have you read David Hume?
I have. It's actually I started as a political science major, and there was a political philosophy class I had to take, and almost kind of randomly I chose to read a book by David Hume because we had to kind of pick a book and write a report about it, and I think that was my gateway drug towards cognitive science.
Yeah. Just to be on this for a second, there are two opinions about David Hume, and I think both are right. And I'm curious where you stand. One is that he was not an empiricist, and one is that he was. Where do you stand?
Um, I think I stand with the kind of classical view that he was an empiricist.
Mm.
Um, but I mean, I can see the pull of the opposing argument because so Immanuel Kant said that he was woken from his dogmatic slumber by reading David Hume, and Kant is famously not an empiricist.
Yeah.
And so I kind of read David Hume as a like someone who pushes empiricism to its logical limits. And you find that if you push empiricism to its limits, then you're forced to quite an extreme degree of skepticism. And then
Hmm.
that's a reason in itself to be skeptical of empiricism.
For people who might not know, can we just make this kind of grounded and concrete? Like, just like, what was the basic argument? This is going to turn into what do you know about David Hume? Dial a friend.
Yes.
Yeah,
Well, I mean, at least for my purposes,
yeah,
what I find interesting is his argument about causality.
yeah.
Because so David Hume was concerned with why it is that we can come to have causal knowledge at all. Okay, and so he observed that, well, we can come to know that there is an association between the presence of clouds in the sky and then rain. And I know day after day we see that when there are clouds in the sky, rain follows.
Mhm.
And so we form by induction this kind of sort of strong association between those two things. But then it seems that in order to really come to the conclusion that there is a causal relationship between those things, that the rain causes that the cloud is the cause of the rain, then there's an extra step that we need to take. And it is not clear that this take can be justified in a rational way.
So the idea
Um,
is that so I've always seen clouds, then rain, clouds and rain. And then I say, look, clouds cause rain. And somebody asks me, well, how do you know that? And I say, well, they've always preceded that. And the argument is that, well, yeah, that's your data, but where do you get the conclusion that that caused that? Maybe it was something
yes,
else.
yeah, exactly. And it's quite difficult to justify that.
Hmm.
Um,
Is this just the correlation causation fallacy? Because you could say, well, no, clouds don't cause rain, rain causes clouds. Or maybe some other thing, maybe Zeus getting angry causes both, right? Um,
Right.
so how do we know that it's the causal arrow is going from clouds to rain? Is that it, or is the skepticism deeper than that?
So I think this might be pushing beyond my
Yeah,
philosophical expertise,
yeah,
but I would say that maybe the worry is even a little bit deeper.
yeah.
Uh, the idea is that even if you can sort of exclude those alternative explanations, so even if you can
Mm,
definitely exclude that the causal direction is not from the rain to the clouds,
mm,
then you still have the question of what justifies me to think that there is a causal relationship.
mm.
Um, and we're kind of getting into the territory of um, it is a bit weird to posit something like a causal relationship. This is not something that we can see.
Yes, yes.
yeah.
It's
And so
not
there is
in the data. Yeah,
yes, there is a leap of faith that we have to take
Yeah.
regardless.
And I think
hmm,
like this is something I was worried about before we had this conversation, and I want to like clear away because I remember when I first started learning about like causation and things like that as an early student, I found it very obtuse. Like this kind of thing where it'd be like, okay, yeah, no, whatever. Like, of course, clouds cause rain, whatever. Why is this important? And I think it's worth like just taking a step back to just dispelling like why this is not obtuse and why it's actually really important. And I think the cloud thing is a good example where my understanding is, and like why I now find it not at all obtuse, but like it's fundamentally like the same non-bullshitty thing as like kids asking, well, why? Like that's a simple non-bullshitty thing. And my understanding is that it is kind of like David's thing, where it's like clouds rain, clouds rain. You've always seen that relationship, but you don't know. It might be something else. And the problem of induction is really just that it's always correlation. Like that was kind of my read of Hume was like it's always correlation, and it's weird that people don't represent that. Well, I have a tentative guess that it is a correlation, but I should reserve in my mind the fact that maybe that's just a correlation, and I don't have this idea that no matter what, and especially in the future, it's going to be the same way. Like I'm really taking a leap of faith in saying the way it is today is the same it's going to be tomorrow because I don't have all the information I need to make that leap of faith. And then therefore you could be wrong. And to my mind, like that's the problem of induction is it's always correlation because there's an infinite number of causal relationships that the correlation you've seen so far is not determinative of what the actual underlying causal thing, and that's the obtuse way. But the simple way of putting it is like if you don't know why something happens, you might be wrong in the future. And that's my read. And that sort of grounds it in like non-bullshit, like this is a fitness problem. Cause like you gotta know, like, did the tiger eat my friend for X reason or Y reason, and can I be go back there tomorrow? Like that's not bullshit. That's not like, well, is it causation or correlation? But we know it always like this is like really like real stuff here. I just so that's
Yeah.
my yeah, clearing of that.
Yeah, very often, not often, hopefully, but sometimes it will be a life or death matter.
Yeah,
Uh,
exactly. Yeah. I don't know.
and
What do
one, I
you,
mean,
yeah.
one example to one reason why it's important to represent causality instead of just a pattern of correlations is that storing, having a predictive model of the world that is just a pattern of correlations is not a very stable way of representing the world. Right.
Right.
So, I mean, you might notice that there is a high correlation between there being rain and then the grass in your garden being wet. And you store the fact that the correlation is maybe zero point 0.3, right? So far, so good. But maybe you install a sprinkler in your garden and to water the grass. Now, once you do that, then the correlation between the rain and the grass
Yeah.
being wet is going to be much lower,
Yeah.
right? And this is not something, this is not something where you have a nice procedure where we can say, well, I can just adjust the correlation based on this new information,
Yeah.
right? There's
Mm.
nothing in the correlation that really tells you how you're supposed to do that.
Yeah.
Instead, if your representation is a representation of is a causal relationship between the rain and the grass being wet, then you can incorporate this new information that there is a sprinkler in a much easier way.
Mm.
Yeah. It's like Paul Smaldino calls it being brittle, and he uses the example of science, right? So like if you have this thing of like, I think we use the example, I think Noam Chomsky talks about this, is you could have a model, a correlational non-causal model of leaves falling,
Mm.
just describing the data. And that's what like a lot of science is, like especially social science. It's just describing the data. But then that's not going to work for bowling balls, how they fall. That's not going to work for a lot of other things. It's very brittle. It only applies to that context. And you don't even know what the context is because you don't have a theory, because you don't have like coefficients of drag and accelerations of gravity. You just have the descriptions of the relationships. And so the whole replication crisis, or like the this effect holds in this context but not another one, is the scientific equivalent of exactly what you're talking about. That it's this, as Paul Smaldino says, it's this brittle thing that as soon as you try to pick it up and move it, it's like a tower of blocks and it just falls apart.
Yeah, and I mean, to be clear, having a description is a good starting point. Sometimes sometimes you can't really start by having a nice theory. You need to gather a lot of data. But it certainly cannot be the end goal of a science. And yeah, and because we should ideally be extracting the invariants, the things such that if if you look at a different context, you know that the invariants are still there and you understand how they work, and then you can make new predictions.
So, to me, this is a lovely example of instinct blindness and making the natural seem strange. This idea that causality is not in the input itself; it's something that the mind constructs. In the same way that, the mental states of other people, there's nothing in you looking in one direction that necessarily says that you know what's over in that direction, right? That's something that I'm projecting onto you. If you're moving really quickly toward a particular object, I'm projecting the fact that you want that object, right? That's not in the data. In the same way as, I'm picking up this coffee mug and drinking it, and when I put it down on the table, there's nothing in the sensory stimulation on the coffee cup that says it's my coffee cup, that it belongs to me. Ownership is another thing that we project onto the world. And what's lovely about your work is that we're doing the same thing with causality, right? And in some sense, we're constructing it. So to me, that leaves the question of how we are constructing. So given that all we're getting is just photons hitting the retina, vibrations hitting our eardrums, how how do we take that information and construct causal relationships out of that data?
Yeah, and can I add to that question really quick? What is it that we're constructing? Like, what is it,
Hmm.
software? Like, what does
Yeah,
it mean that we have a causal That would be great. Thank you. Yeah, yeah.
yeah, and that last question is the first question that we should ask, obviously.
Hmm.
So, I mean, I take it, and a lot of people who are working in the field of causal cognition take it that the goal is to construct a causal model of the world, or at least a causal model of the particular system that we're interested in. And so this causal model will be made up of variables and then the causal relationships between them. So if I have a causal model of the rain, then maybe one of my variables will be the presence of clouds in the sky. Another variable will be the presence of rain, and then we will have another variable that is the grass wet, for example. And then we can express the causal relationships between them. So what is the causal relationships between the rain and the clouds? And then what is the causal relationships between whether the grass is wet and the rain? And there's various formalisms for how you might represent those causal relationships. And we don't need to get into the details. But basically, something that is quite important and that is kind of foundational to the way that we think about causality is that the relationship between two variables is asymmetric, right? So it's not just that we know that there is an association between clouds and rain. It's just that there's this asymmetry that it is the clouds that are causing the rain and not vice versa. And so one way to actually represent that fact concretely is by building into the model this commitment that if we were to intervene on the clouds, then this will have a downstream effect on rain. And so if I had some magical powers and I was able to prevent the clouds from forming, then there would not be any rain. Right? But if I were to build a giant dome over the city that shelters us from the rain, this would not make the clouds go away. And so that is the way that we kind of build in this important distinction between something like X causing Y and Y causing X.
So just to, we can keep going
Yeah,
on, but just to clarify, so what I'm hearing is, because it's hard to talk about this because this is again where natural language fails us, is that
yeah,
if we snip out the word causal, if we're trying to explain what a causal relationship is, and we snip out because we don't want to use the term in the explanation, it's a relationship that, excuse me, is it's a relationship that has like directionality, and then also it sort of picks out um, what is likely to, if one thing is present, another thing will be present in sort of a compositional order dependent way. So it's sort of saying, like when this bit of the world is there, I don't even know how to talk about it, but yeah, right? Like is that fair? Like it's sort of that, this is necessary. I don't even like using the word necessary, but it's just it's these placeholders for you can't change the order, and then if you manipulate this thing, this other thing, they're kind of attached to each other in terms
yes,
of
yeah.
outcomes
So
in the world.
this
Yeah.
this notion of manipulability is quite important. So
Yeah.
sometimes we talk about interventions of manipulability, etc. But it's this idea that if someone could kind of reach into the system from the outside
Yeah.
and change the state change what happens to
Yeah.
at some node in the network, then you will have particular effects somewhere.
Right. I
But
like the
that will not be,
example. Yeah, I
yeah,
like the example of moon and tides. Like
yeah, yeah,
nobody's ever grabbed the moon, but the theory is that the causal theory of
yeah.
moon and tides is if somebody grabbed the moon and moved it, the tides would be different.
Yes, and it's quite remarkable that we can entertain this, despite
Hmm.
the obvious impracticality of actually moving the moon. It's something that's quite easy to imagine,
Yeah.
to think about it. And if you were to explain to someone how tides work, then that would be one way to do that. You can say, well, yes, if we move the moon, then the tide would happen in a different way. And I guess the person that you're trying to teach to would not be bewildered at the idea. They
Right.
would. I know maybe in certain cultures this is a bit strange to teach things in that way.
Yeah.
But I guess the general idea is quite intuitive.
Yeah.
So it seems like what you're saying is that causality is ultimately about hypothetical actions, and that if I think A causes B, what that means is just I'm just translating that into the language of hypothetical things I can do. If I add A, I'm going to get B.
Yep.
If I take away A, then B goes away, right? These are hypothetical, but even if I'm incapable of taking away A or adding A, if I don't have magical powers, I can't do anything about the clouds. Merely the ability to entertain the possible action of adding or removing A will have an effect. I'm using the word effect, but will change B. That is ultimately what causality is. It's framed in terms of hypothetical interventions or actions or impacts you could have on the world, and what is going to be changed in the world as a result. Again, I'm using the word as a result, which gets us back
Yeah,
into
As a
causality.
exactly.
But
circular.
Yeah.
what? So it's about hypothetical actions, right?
Yes. Yes. It's a great way of explaining it. Um, and I think that the fact that are we are quite able to entertain those hypothetical actions. Um, I think this is one of the best psychological evidence we have that people are constructing causal models of the world, right? They're not just passively trying to store patterns of correlations in that results from their experience, right? Because I have never experienced a state of the world where the moon has been kind of changed course. Um,
Yeah.
but I can imagine a manipulation that would do so. Maybe a better example is I have never imagined the state of the world where the sun suddenly disappears. But I can quite easily imagine what would happen if a sort of an action, a hypothetical action was taken and the sun goes out. And this, I mean, if you are looking at the mind from a sort of behaviorist perspective, where all you're doing is keeping track of associations, maybe keeping track of the result of your own actions, you would not really predict that people have the ability to engage in that kind of thinking, and you would even less predict the fact that people actually quite like thinking about those sorts of things.
Yeah. It's also a point like I don't know who made this point or maybe I don't, whatever. Is the associationism never really talked about what is done with those representations either. Like it was very much explain the data given the study. But yeah, like the problem, like a good example also is the desert ant, where it goes out, it has polar light sensitive thing. It does dead reckoning where it encodes distance by steps and angle of the sun as it moves. And then it does that integration when it finds prey and goes back to the nest. Um, if you just say, well, it's just associating stuff. Like there's no notion of like what the association is for. But the second you have this thing of like, well, the whole point of doing the association is creating some representation of where the nest is. That's very much like a model, right? That's integrating stuff for a purpose, and it allows you to predict and go on a novel dead point line to where the nest is so you don't fry yourself in the desert, which is why it's a selection pressure. But no, I like that this is very evolutionary um, in a way. Is this causal model literature evolutionary, and what does evolution buy you that may not be in the literature, or is it? I don't know. Yeah, is that a coherent
Yeah,
question?
no, that's such a great question, I think. Um, I would say that the causal cognition literature is implicitly evolutionary. So it definitely has a functionalist bent, right? So people who look at causal cognition, they ask, well, what is the purpose of the system? Why should we have those computations? And it's really committed to this idea that people are building representations. And so there's also this very strong commitment to optimality, at least as a sort of methodological heuristic. Because I mean, once you have this machinery of causal models, you can ask, well, what is the best way to work with a causal model? So, like, for example, you're trying to learn, well, given all the data that I have, what is the probability that what is the probability that it is raining right now, given that all I can observe is that the grass is wet. And this is something that you can solve using the mathematics of probability theory. And so it's basically a Bayesian inference problem. So you have to set up Bayes' theorem, and then you can work out what is the probability of a cause given the effect. And so we can look at whether people actually engage in causal reasoning in that way. And to what extent is it the case that when people when people make those inferences, they are actually reasoning in the normative way that is described by probability theory. And to some extent they do, and to some extent they don't. And so, but the fact is that your ability to express this problem makes it easy to have hypotheses that can be tested, right? And from my own point of view, as an evolutionary psychologist, I think that another justification for the optimality analysis is that you should expect to a first order of approximation that people will solve those problems in the normatively correct way, because there have been a relatively high selection pressure for people to really be good at causal reasoning.
Yeah.
So that's the first part of the answer. The second part of the answer is that people who do causal cognition, they are often not they're not quite concerned about domain specificity in the way that most of us would be concerned, right? So we're not going to ask, well, what are the principles that people draw on when they think about biology, for example. And I guess one motivation behind this choice is that there are general principles of causality that are supposed to apply across the board. And so this idea that causality is a matter of intervention, and that you need to engage in some sort of Bayesian reasoning in order to engage in causal reasoning, those are things that will apply regardless of whether you are thinking about psychological reasoning or biological reasoning or physical reasoning. And so, I mean, to us, at least from the outside, this can appear as something that is very domain general. But I would argue that there is a justification to that, because you can think of the domain as being causality, and you have certain invariants of good causal reasoning that will apply across the board.
Yeah. That's great. Yeah.
It's interesting. If causality is ultimately about things I can do, like what will happen if I do this. Well, that's basically almost pretty much all of what the brain does, is trying to figure out what I should do. What will happen if I do this?
Yeah,
Like
exactly.
it's a machine for figuring out what to do. And it seems like causality should be literally a part of every system in the mind, because every system in the mind is ultimately about what should I do next, right? What's going to happen if I do this? What's going to happen if I do that? So I think you could think about it as, ultra domain generality, but I don't think that's a really helpful way to think about it. I think it's better to think about it in terms of functional specificity. We have systems that are functionally designed for the purpose of picking out causal relationships. And that should, by design, affect every part of the mind that is involved in figuring out what to do next.
Yeah, and can I just elaborate too? I think domain generality is, or just the whole issue of domain, like the word domain, is, if you look at how people use it, I think it's exceedingly unclear. If you look at how Fodor uses it, it's very folk psychological, where like a domain is like a thing out in the world. Like, is it like cheese versus like cows, right? Like that's a domain. There's remarkably little like notion of like once you start thinking about the psychology, what do you mean by domain at all? And I would put it as like what David just described, which is exactly right, is you have all these systems for representing all this stuff out in the world. And all of those systems are all very specific for making all those representations possible while you're representing objects of the social world or physical relationships or emotion, mental states, like all these things in specialized machinery. Once all those very specific systems are all working, they're also generating formats in this like event system that can take many of these inputs in because of all this very specific machinery working. And it's that event system being fed all of this content where that has these rules of sort of like well, if I do this, this is the other thing that's going to come along with it, and these other things don't matter, which applies to lots of relationships in the world. Yeah, that's common to all of them, but it's that there's more and more specialized machinery. There's even machinery for that job. I mean, it might get replicated across systems, who knows? But I think this is a thing where, like, if you say it's domain general in the sense of it applies to cows and cheese, it sort of sounds like, well, one mechanism does cows and cheese, but it's actually there's a ton of there's even more mechanisms than just if there was one mechanism for cows and a different mechanisms for cheese. It's actually there's more mechanisms that allow something to be domain general in the unclear way than the domain specific way. I don't know if that's helpful for this, but I just always have this rant of like, my God, domain general versus domain specific is like it's I think it's even worse than innate and learned, or it's just as bad. Yeah.
Yeah. I mean, I agree with that. I think to some extent, this was a thing that um, it's a nice set of concepts to use if you're not already being in the process of thinking about things in a functional way.
Yes,
This is
100%.
this is kind of a
It's
way
a
that you
gateway
can
drug. Yeah, it's a
yeah
gateway
it's a
drug to
gateway
functionality. No, totally. Yeah.
where you can use people's intuitive
Yes,
understanding of
exactly.
the
Like
world and
100%. Yeah.
So you mentioned that we have looked at how well people conform to normative standards of causal reasoning or Bayesian reasoning, and you mentioned that there are some cases where we fall short of the normative standard. What are some of those cases, and what do you think might be going on there?
oh yeah, so there are many things we could say about that, and
Okay.
this could be its own discussion. But I think maybe I can talk about two case studies that I think are quite interesting.
Okay.
And so the first case study actually illustrates the fact that our brain is wired up to represent the world in causal terms.
Yeah.
So if you read psychology from the 70s, 80s, there's a bit of a pessimistic picture that emerges about how good people are at reasoning. So I know there are studies by people like Tversky and Kahneman, and one classic example of that is the diagnostic test problem. And so in that problem, you're told that there's this disease that maybe 1 in 1,000 people have, and there's this test to see if you have the disease. And you're told that the test has a certain false positive rate, and it has a certain false negative rate. And putting all this information together, you can, in principle, compute what is the probability that you have the disease, given that you were tested positive to the disease. And when you ask participants, what is this probability? Typically, they will say something like, oh, like 80%. They will say something pretty high, even if the numbers are set up in such a way that the answer is actually something like 7%. And so that is a huge gap between the normative Bayesian answer and the correct answer. And so when you look at that, you can maybe conclude, well, it looks like people are actually terrible at probabilistic reasoning. But then if you look at the way this problem is set up, you are never really given an explanation for why there might be false positives. You kind of just told that, well, sometimes the test doesn't work very well. And so it is difficult to for the participant to construct a causal model of the situation that they have to reason about. And so one hypothesis that is just the explanation for why this is a hard problem.
Mhm.
And so some psychologists have done an experiment where they modify this problem in a slight way, and the only thing that they do is that they say, well, sometimes people, like, I don't know, maybe 70% of people have a benign case that
Mhm.
will cause a false positive.
Mhm.
And when you reformulate this problem in that way, then people suddenly they have a sort of a causal explanation that is available to account for the presence of false positives. And now their answers get much closer to the Bayesian optimum.
Mm.
And so it seems that people are able to engage in good Bayesian reasoning, but they need to form a causal representation in order to do that. And
And
so, yeah.
yeah, sorry, in that example too,
Yeah.
just really quick, I think there's also additional work showing that if you do this with frequencies, so you show people this is the number of people who have false positives, this is the number of people who have the correct hits, it also goes away in the sense of the Tversky and Kahneman result was actually very improbable and it was really designed. My friend and colleague Tomas Leharaga has a paper in Psych Bulletin about how people used to see people say that people were good statisticians, and Tversky Kahneman reversed that, but they were using very abstract, non-evolutionarily valid sort of cues of like, not using whole objects or frequencies and sort of giving people counterintuitive things. So I just want to say like that's really interesting that even just changing adding the causal model is like another problem with that methodology. So
Yeah.
yeah.
I mean, and to some extent, I think that Tversky and Kahneman, they still did a service to the field by pointing out that there are those cases where people do really, really badly, right? Because then see something that is crying for explanation, and then when we explain why is it that people do very badly, we learn new things about how the mind works. Yeah, and so yeah, the second example that I think is interesting is this principle. It's almost well, it is actually an axiom of causal reasoning that is called the Markov condition. So it's named after this mathematician from the early 20th century called Andrei Markov, who studied very simple systems where the state of the system in a particular time just depends on the previous state of the system. And this is relevant to causality because if you have a causal system where suppose you have again the clouds cause the rain and the rain causes the grass to be wet. If that is all there is to your causal system, then the clouds can have an influence on the grass being wet. Right? So if there are clouds, the grass are more likely to be wet. But the whole causal influence of the clouds can only go via the rain. Okay, so the only reason that the clouds can make the rain wet can make the grass wet is by making it rain, right? And so there's from the sort of perspective of causal reasoning, then the Markov condition is just a fancy way of saying that once you know whether it has rained or not, then anything that you learn about whether the clouds are there or not should not give you any more information about whether the grass is wet.
Mm.
Right?
You got the most important piece of information.
Yeah, I mean, you get all the information, right? And sometimes
yeah.
we say that the rain screens off the influence of the clouds. And so what this means is that if you're asked, well, what is the probability that the grass is wet, given that we know that it's been raining, you should give some answer, right? And then if later on the experimenter asks you, well, what is the probability that the grass is wet, given that it has rain and there are clouds? You should give the exact same answer, right? But people don't really do that. People will give a higher probability if you tell them that in addition to the fact that there is rain, there are also clouds. And it seems like a blatant violation of the rules of how you should reason with causal networks. And so this has gotten people in the field quite interested because you want to explain, you want to account for that in a way that is consistent with the fact that people are actually reasoning with causal models. And I think a nice explanation of why people do that is actually that when they need to engage in probabilistic reasoning, they make use of approximations. And the reason why you need to engage in approximations is that computing a probability will, in general, be relatively expensive in computational terms. Right? You need to engage in quite complex computations, and there are actually shortcuts that people who do computational statistics and machine learning typically use in order to make the computations easier. And it turns out that if you assume that people are engaging in the same kind of shortcuts, then you predict that they will make that kind of mistake. And so the picture that emerges from that is not that people don't know the rules of causal models, but they use some approximations in order to compute things in an efficient way.
I'm a little bit confused. I mean, I hear what you're saying, but let me be devil's advocate for the
Yeah.
So like with the rain and the clouds, is the study design that like you tell the same person rain and then the same person rain and clouds, and which one do you think is more likely that the grass is wet?
So there are various ways that the experiment has been done. And of course, when people do those experiments, they use a more controlled setup where you say,
Yeah.
well, there's this machine, and then there's this component of the machine that can influence this component that then can
Yeah.
influence that
But
component.
why is that? So why is it wrong for me to be more confident that the grass is wet if I say clouds and rain as opposed to rain?
So if I ask you, suppose you know that there is rain,
Yeah.
what is the probability that the grass is wet? Then the answer you give to that should be the same as if I ask you, suppose you know that there is rain and there are clouds.
Yeah, but I would push back on that because
Yeah.
like that ignores that like is it's very like I mean, I don't know. I'm not saying you're doing this, but I'm saying like the causal model people, like there's a difference between like there's a little bit of rain versus like there's a storm, right? So like there's just differing, I mean, in some sense, people
Yeah.
I mean, just to take a
Yeah,
step back, like
yeah,
causality doesn't exist. It's a representation of the mind of like how certain am I likely that this event will produce this event.
Yeah.
And if you tell me rain versus rain and clouds, um, how likely is it that the grass is drenched? How much water is there? How
Right.
likely is it that that was rain and not like a bird peeing or something? Like that's all relevant. And if you tell me like there was a little bit of rain versus like there's rain and clouds, like just if there's all this common sense knowledge that I think a smart computer would say it's much more likely that whatever you're trying to communicate of like how likely is it the grass is wet, how wet it got, how confident you were that like, it was a
Right.
rainstorm. All these
Or
things make sense.
yeah, or
It
or even
seems
like
to,
the
yeah,
person who's telling you that it's raining without clouds, like maybe
yeah,
you should not trust that
yeah,
person. Maybe they were
exactly.
wrong.
Yeah,
Like,
like if
yes.
you've ever felt rain when there's no clouds, you're like, what is this? And it does happen, right?
yeah.
Because like the wind is strong. So like
Yeah, I think
I don't I mean,
no,
maybe we're
I think
hanging a lot on this example, but like
no,
it
I
seems
hear
it seems
what you're
like the
saying, and
scientists are wrong.
I
Yeah.
think I think that those are good objections to sort of the experiment in the way that I described it.
Yeah, exactly.
Of course, in practice, when people do those experiments, you have a much more controlled setting where you really make it clear to people that, well, those are just binary variables, and really the only way that this, like the end variable, the only way that this could be affected is by the state of the previous variable. And so that way you bypass that kind of concern about, well, what inferences people are making from the fact that you tell
Mm.
them many things and so on and so forth.
But isn't it still rational in the sense of like, shouldn't an evolved psychology represent? Because, like, I mean, from an evolved psychology perspective, it should acknowledge that all it can do is pick up on correlations, right? Like the evolved psychology is only ever detecting co-occurrences and is using the fact that some co-occurrences are actionable for intervention and actually generally produce the right outcome, right? Like, so that's what we mean by causation, but it's all a guess. So it strikes me as like I mean, maybe this is, maybe I should get more concrete, but I don't know. I feel like the scientists are wrong in this case, and that it's a smart system to be, if more predictors are present, you should increase your likelihood.
Yeah. I mean, I have a version of arguments that I've made in print, which is that so I mean I buy this idea that I described, that's kind of, if people engage in shortcuts in their computations, then they will make the kind of mistakes that have been observed. But a different way that those kinds of mistakes will be produced is that if people don't completely buy the story that has been given to them by
Yeah.
the experimenter. So
Yeah.
maybe they think,
Mm.
well, the experimenter tells me, well, those variables are causally related, but I don't know, maybe they're not, or maybe they're related, but in a different way than
Mm.
has been told to me. And so if that's what you think, then the smart move is to just maintain those different hypotheses
Yes.
in mind,
Yes.
and
Mm.
then to average over them. Right?
Yes.
And so
Wait a
and so
This
what
is
second.
we
what I
So wait
was
a second.
doing
You're
actually.
telling me
Yeah.
that people aren't assuming that experimenters in psychology experiments are infallible and omniscient?
What if you let people do the experiment themselves? Like, has anybody ever done that? Where like you actually give people the ability to actually test the relationships themselves? Like the
Oh, I see.
experiential format of teasing apart what causes what, as opposed to somebody telling you. Because actually, thank you. I felt like I was hemming and hawing, but that's exactly what I was doing. I was like, I don't believe you. That's exactly what I was
Yeah, yeah.
doing.
And what we've have shown in that paper is that, well, if you assume that people have this uncertainty and that they are averaging over that uncertainty, then you predict the that they will make the kind of quote unquote mistakes that
Yeah.
have been observed in
Yeah.
these experiments. But to answer your question, I don't think that experiment has been run where you really allow participants to manipulate the causal structure themselves. That's it. Yeah, it would be interesting to perform that experiment, that's for sure.
Yeah.
So is your take that this idea that humans are bad at causal reasoning or they're irrational, that we deviate from normative standards, is your take that this idea is overblown and that actually if you dig into the details and operationalize things in a sensible way and in an ecologically valid way, that actually people are pretty good at causal reasoning and fit pretty closely to what you might expect an optimal system to look like?
Yeah, yeah. And I think that's a good summary of what I think. Um, and if you were to try to come up with a taxonomy of possible sources of mistakes that people make, I would say that there's maybe two main sources of mistakes that people can, for why people might make mistakes. And the first is this kind of representational issue where people just either don't really believe you, or uh, they're not able to construct a causal model that that would actually allow them to solve the statistical problem. There's a different way that they could be wrong, is that if the problem is super complicated, then of course I mean it's kind of, it's a bit of a trivial point in a way. It's like asking people, if I ask you, what is the 17th digit of pi, and you give me an answer that is no better than chance, there's a sense in which you're not being normative, right? But it's just that the
Mhm.
computational demands that I put on you are
Yeah,
too high. And so that's
yeah.
is one way that you can make mistakes. And I mean, one other domain in which I have shown that people are relatively they're quite good at following the normative principles of probabilistic inference is in the social domain. So when they have to infer the welfare trade-off ratio of other people, then they have to solve a problem that is actually quite sophisticated. If you were to think of, they have to make probabilistic computations over a causal model of how other people make decisions. Um, and and yet, despite the complexity of the problem, they're actually quite good at inferring how much someone else values them. So this is a series of experiments that we've done with John and Lida, where the simplified version of these experiments is that you see someone kind of sharing a pot of money in a particular context, and you see the decision that they have made. And then there's a slightly different context where maybe the cost to them of giving you money is a bit higher. And
So
I
maybe like
ask you,
they're splitting food and they're hungry or something like that.
Something, yeah, it's a
Okay.
good picture.
Okay.
And so in that context, so you know what they have done in that previous situation. And I ask you, what is the probability that they will give the food to you? And,
Hmm.
and so you can compute what is the, like, given some assumptions, what is the normative probability that a Bayesian model would give.
Hmm.
And what we find is that first, people are quite good. The people's answers are quite aligned with the answers that are given by the Bayesian model.
Hmm.
And the second cool thing that we have found is that we also asked people, um, well, how grateful are you, when the person actually, because you actually at the end you learn what they have done. And
Hmm.
so if the person in the experiment gives you something, we ask people, well, how grateful are you that you were given that thing? And if they decide to take the selfish action, we ask, well, how angry do you feel? And then what we found is that the best predictor of how angry or grateful the people feel the best predictor is not how much they get or how much they fail to get, right? Because
Hmm.
we control for those things tightly. So like the kind of the payoffs that are involved are controlled across trials. Um, and the sort of opportunity cost is also controlled. But
Hmm.
what we can do is we can actually compute the welfare trade-off ratio that an ideal Bayesian observer would infer the other person has on the basis of the decisions that you observe. And then this inferred welfare trade-off ratio is actually quite a good predictor of gratitude and anger. So
Hmm.
basically, if you infer that, if an ideal Bayesian observer infers that yes, this person does not care at all about me, then I'm going to be quite angry.
Even if you end up getting a lot.
Yes, yeah.
Yeah.
But yeah, so kind of the intuition is that suppose at some point they give me a lot, but because it was trivial for them to give me,
Yeah. Yeah.
like
Mm.
the cost again was super super low, and
Yeah.
then
They were going to throw it
on
into the
the
garbage or whatever, and you just happen to be there. Yeah. Whatever.
yeah, exactly, yeah, exactly.
Yeah.
And then on in the other occasion, they could have benefited me by a little bit, at again a trivial cost to themselves.
Mhm.
And they decide, oh, yeah, you know what, I don't really feel like giving it to you. I'm going to take the 2 cents or whatever instead
Mhm.
of giving you $10.
Mhm.
And here, you just lost $10. It's not that much, but like, you did it just to save 2 cents. Like that's you just don't care about me at all. And so that is what elicits anger. And of course, this is not my own theory. This is the work of Aaron Sell. But what we were able
Mhm.
to show in that paper is actually you can create a computational account of how anger follows from observations of what the other person has done.
What does that mean? I mean, I think people might have two questions, and this is both hard. Why you and I have talked about this today. Like, what does it mean to offer a computational account? Because you straddle two communities. We've talked a lot about functionalism or like a software level description, but then there's also like a technical, methodological use of the term computationalism. Uh, and then there's like computers, like a laptop. Like for people, because there's different audiences, can you explain what does that mean, both to like a general audience, but also like evolutionary psychologists who might be used to like functionalism. Yeah, what does that mean, computational?
Yeah, yeah. That's, I think, a very important point. And it's a bit of an unfortunate fact about the history of psychology that you have these two different meanings of computational, right? So the first meaning of computational is maybe the one that will be most familiar to people across the sciences. So it's the idea that we're going to use mathematics, or we're going to use computers in order to help us do our science. Okay, and so within that meaning of computational, you are engaging in in computational work every time you compute a linear regression, or when you compute a t-test or something like that, because you're using a computer, you're using mathematical principles in order to make inferences.
Right. And it's
Um,
sort of just standard, it's just sort of like rules of deduction and just sort of force, like, if you know what the inputs are, it's just some deterministic process produces some outputs. that's that, right? And it's just certain ones work for whatever reason.
You
And
don't have to do it on computer. You can
yeah,
also,
exactly.
you could compute your t-test on paper
yeah,
to
exactly. I've
take
done
your
that
load. That
before.
would,
Yeah.
yes,
But
you would
back
still
in
be
when
engaging
dinosaurs
in,
roamed the earth, yeah, I had to do that.
you'd still be
I
engaging
don't
in
remember
computational
anything
modeling.
from it. Yes, exactly. Sorry. Yes.
Uh,
As I
yeah,
rode
when
a
I was
horse
at
to the
UC,
schoolhouse and played with an
when,
abacus. Yeah, exactly.
when I was at UCSB, actually, we had to compute matrix multiplications by hand in
Yeah,
our
it's probably the
when I for
same. Was
stats
it
tech.
Greg Ashby?
This, I think it was the person who was replacing Greg Ashby
Okay, yeah.
for that one semester because he was on leave. But
Mm.
yeah, and we were given no explanation for why this was the
Exactly. I
case.
did the same thing. Yes, exactly.
Anyways,
Anyway, but yeah, so that's everyone understands computation in this sort of way of
in
using
that
either
sense,
math or for more complicated systems, computer code, but it's still the same principle where it's just deterministic rules. It's just deduction in sort of a scripted way that
yeah,
is
yeah, yeah.
sort of known. Yeah.
And obviously, this is a super powerful tool, and it's helpful in quite a lot of ways. But the second meaning of computational that is more specific to, I guess, psychologists and neuroscientists is being interested in the computations that are performed by an organism, like typically the computations that are performed in someone's brain. So it's really making theories about information processing. And interestingly, the two meanings can be dissociated, right? So I can have a theory of the computation that someone is performing, or that a theory of the computation that a given part of the brain is performing, that can be expressed in verbal terms,
Mhm.
right? Another version of that is that I can have a very simple computational theory. So if we go back to the theory of anger that Aaron Sell gave, the equation is quite simple. It's just for those who don't know, it's an equation that determines how someone decides whether to help based on this parameter that's called their welfare trade-off ratio. And then you decide to help given that your welfare trade-off ratio is above. So if the costs and the benefits of your action of the potential actions are related to the welfare trade-off ratio in a certain way.
Right.
So this is a computational theory in both senses, right? Because you can express it with an equation. And you're also telling something about the computation that is taking place in someone's brain.
Right. So if welfare trade-off ratio is
Yeah.
1, it's like, well, if you would get $10 and I would get 9, I would just give it to you because it's more. That's just the same. But then it's like it's just it changes the cost and benefits. So like for my son, I might have a positive one where like even if I get 10, but he gets 7, I still might give it to him because I care about him more than I care about me. And so it's like a very positive welfare trade-off ratio. But then if it's like a negative one, and yeah, or a very negative value, then I might, be willing to incur a cost to make sure you don't get a benefit. So just to make it slightly more concrete. Yeah. Sorry,
Yeah.
but that's just
Yeah,
it.
no, of course, that's
Okay.
a great summary. And so, I think, a lot of evolutionary psychologists think that having those computational theories, like those theories of what is the computation, is extremely valuable. And this is valuable even when those computational theories are actually not expressed in computational terms. Even if you don't have equations or computer code in order to explain the theory.
Yeah.
Of course, maybe the ideal case is when you have both, right? When you have a computational theory that is expressed in equations or in computer code. But then there's another quadrant in the space of possibilities, right? There's a quadrant where you're using very complicated mathematics, but you're not saying anything about information processing.
Exactly.
And that is, it's often very useful, right? Sometimes you might be doing sociology and don't care at all about how the mind works. It's a very valuable thing to do.
Yeah.
But then the sort of problematic part of this quadrant is that when you are a psychologist and you say, look, I have a computational theory of X, and your computational theory is indeed, there's a lot of very complicated mathematics. You can implement it, you can run nice simulations. But when you look at it a little bit better, then you're not actually really saying anything about information processing in the mind. Right?
Yeah.
You're just modeling how the observed variables are actually related to each other.
Yeah, I think that's a
So
really
yeah,
important,
yeah,
profound point. Yeah, you and I have talked about this. What does it mean to be computational? Is like a paper we should really do. I think a
yeah.
good concrete example of this would be just describing, like, to make it super concrete for people, just a bicycle, like to the extent people know how a bicycle works. Like, you could have a verbal model of how a bicycle works. Like, you push the pedals, it turns the crank, it pulls the chain, it pulls the cassette, it turns the wheel. That's all verbal. I could have a very nice mathematical description of like how fast the tire rotates and like sort of some other parameter, like I don't know how often the chain vibrates, that has nothing to do with explaining how the thing works. And if you just like, if I typed up the functional description and if I made a beautiful graph of the fluff, and you just did superficially like which one looks sciencier, people would be like, oh, the beautiful graph, you have numbers. Like there's a pragmatic effect that like once you know the function of something so well, you can avoid being qualitative and you can become quantitative. But I believe there's been an enormous, often cynical, frankly, thing where it's like if I make something quantitative, I can lead people into believing that we know understand it so well that we're beyond the qualitative phase and now we're doing quantitative science. It's the equivalent of like putting on a lab coat and being like, I'm a scientist. um, and yeah, it's not a straw man to say like I have sat in on many, 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 many talks that were this quadrant. Yeah.
Yeah, yeah. And there's a version of that ends up connecting back to the issue of correlation and causation, which is this kind of industry of mediation analysis and structural equation models. You can have increasingly complicated mathematical models where someone collects a lot of data and then they puts them inside the computer and then the computer crunches the numbers for hours. And then what comes back is a chart where you have little causal errors between one variable and another, and you can have quite a complicated graph. And again, it looks like you have produced a mechanistic description of the system. But very often, those things are kind of increasingly sophisticated ways of convincing yourself that you have causal insights, whereas you're just describing a pattern of correlations.
Yeah.
Yeah.
Oh,
And we
David, go
shouldn't,
ahead.
I mean, oftentimes the computational aspect of it can be quite simple, as in the case of anger. Like it's actually, when you think about the design of anger, it's shockingly simple. You're trying to figure out, what cost a person would be willing to inflict on you if in exchange for whatever benefit to them. It's just a ratio, literally a ratio. You're trying to figure that out, and then your anger and gratitude should be calibrated in response to that. Like that's a pretty simple computational model. It doesn't require a huge, page of equations or graphs. And so we should be open to the possibility that whatever system we're trying to explain in the mind should be as simple or as complicated as it needs to be for solving the particular adaptive problem. And we shouldn't have a prior that it necessarily needs to be very sophisticated. Or we should at least, be open to the possibility that some parts of it might be actually very simple and some parts of it might be complicated depending on what perspective you're taking or what part you're looking at. Right. Like in terms of the possible inputs to the welfare trade-off ratio calculation, there might be many different inputs and many different contextual cues that go into that calculation. And that part might be very complicated. But what is spit out in the end is actually very simple. It's just a ratio of two numbers.
Yeah, I think you could even go further than that and say that even if you start with the baseline assumption that everything will be quite complicated, there is often value in having a simplified model
Yeah.
where you sort of say, well, of course, we know that the system doesn't really work exactly like that, but it actually is the case that we have a very simple model that gives us a lot of traction. And I mean, this is actually if we look at the history of science, this is the way that things have worked, right? I mean, Kepler's laws of motion, they're not a complete description of kind of the way that the solar system works. We didn't like it's not like the general theory of gravitation and relativity sprung up fully formed. We had to start with very simple models and then we added a lot of complexity. And so, yeah, probably in the sciences of the mind, there's no reason that things should work in the otherwise.
This was a
Right. I think
long, oh, sorry, David, go ahead.
I feel like we often confuse which parts should be simple and which parts should be complicated. The deeper principles
Yeah.
should be
Mm.
simple.
Oh yeah.
What results from the operation of those simple principles can be mind-bogglingly complicated. I mean, the best example of this is the theory of evolution itself. It's extremely simple. You can lay it out in a couple sentences. Darwin laid it out in a couple sentences. And yet, that simple idea, that simple principle gives rise to the most mind-bogglingly complex forms of biological organization, including the brain that's producing these words, is a product of those simple principles. So that to me is the best example of an extreme difference between the simplicity of the underlying causal process and the complexity of what emerges from that causal process. And I think we should be trying to have the same kind of insights about the mind. We should be trying to hone in on what the simple principles are that are producing the complexity of mental and behavioral phenomena. And I think evolution helps you focus your lens on what those simple principles ought to be. What are the underlying goals of an evolved organism? And what are the parameters that we need to be looking for in order to guide behavior adaptively?
Yeah, Tadek, I think I derailed. I think you triggered me
Yeah.
when you said computational. I think this is like a long digression. You were saying you have a computational model like 10 minutes ago. Do you remember what you were talking about? If not, I have we can go on to something
Yeah.
else
I
because I
think I
want.
was just talking about the computational model and the instantiation of the model of how anger
Mm,
follows from a sort of
yeah,
a Bayesian inference about the person's welfare trade-off ratio.
right.
Because I guess in previous work by Aaron Sell, there was this idea that yes, if the cost and benefit ratio is such that this gives you information about the person's welfare trade-off ratio, then you will calibrate your anger accordingly. And so what we did in that paper is kind of to really flesh out like how this would work in Bayesian terms.
Yeah. In Bayesian terms, just so it's not like jargon or fancy, let me see if I do a simple, like roughly 6-year-old level description and you tell me if it's accurate. So like one version of sort of like let's use the cloud rain example, right? You could do something where you're sort of like, well, every time it rains, how often are there clouds? And then you could just sort of say, well, that's how I'm going to figure out how likely it is that it's going to rain. That's one version. But a smarter version would say, well, look, how when it's raining, when are there clouds? But you should look at another category too, which is how often are there clouds and it's not raining. And then you should combine those two. And roughly speaking, that's what being Bayesian is. It's looking at both things and not just the one. Is that a fair, super simple gloss?
Yeah. If we want to go even more at a more foundational level, maybe the idea behind Bayesian thinking is that there's a lot of uncertainty in the world, right? And so, I mean, with some exceptions, we can never be certain of most things
Right.
because of the uncertainty. And so the best that we can do is to assign some number to our belief that something is the case. So maybe I look out the window and I see clouds in the sky, and maybe it's going to rain, but I'm not quite sure. Maybe I will say that there's a zero point 0.9 chance that it's going to rain. And so this idea is that we can quantify our belief in something by assigning numbers. And then the good way to do this, if we are going to engage in sound reasoning, is for those numbers to be probabilities. Right? Because when we have probabilities, then we can work with them and we can combine them in particular ways.
Mm.
And so that's kind of the abstract idea behind like Bayesianism, is that you should really work with probabilities instead of just truth values.
Yeah.
And then this kind of framework is called Bayesianism after Bayes' theorem, because Bayes' theorem tells you what is the right way to update the number that you assign to a particular proposition based on the evidence that you have.
Yeah.
Mhm.
It's we could do a whole 2 hours on what is a
Oh yeah,
probability. We
and
should
more.
not. um, I wanted to slightly change direction. Oh, David, do you have something? I don't want to.
No, no.
Yeah. Of just like we've talked a lot about causation versus correlation, and we've sort of been like, well, look, the mind is actually pretty good at like picking out causation, but there's another sense in which causation doesn't matter at all, and I think this gets into your free will work, which is imagine you have a causal account. Like I don't know, let's imagine you're up on a stage, it's made out of wood, and you slip on a banana and you hit your head really really hard. And you're like, what caused me to hit my head? There's a long stretch of causal sequences, including like the people who chopped down the tree that made the stage, the person that grew the banana, right? Like there's a long stretch of causality that all led up to you hitting your head. But we meaning like psychological design, focuses in on not all of that causation, but the part of the causation that has the highest effective sort of turnover, or it's sort of like, where's the biggest bang for my buck? Like, if I don't want to slip, should I like go to where they grow the trees and like convince them to not grow the trees? Should I like, go to the banana grower and not do that? No, it's like, well, that banana shouldn't have been on the ground there. And so, like, a notion of causation is also it's not just all actual causation. It narrows down to, like, as David describes, sort of like points of intervention or things I could do something about, which is what you would expect an organism to do. And that's coming from your work, correct? That, like, I think you're also making this point that sort of an interventionist view of causation, I think there's other people doing it too, is also very evolutionary in the sense of, even if you grant causal views, it really is a shrinking down of all possible causal sequences to those things you can functionally do something about.
Yeah, and actually the first time I heard about this problem was a talk by John Tooby at HBS.
Mm.
And I don't think he ever published anything of the sort, but
Yeah, I was at that
this is
talk too. Yeah.
all right. Yes,
Yeah.
I mean, I think this is one of those things. It's a great example of instinct blindness. This is a problem that we never think about. Basically, I mean, it's something that has been it has taken quite a long time before people actually started to realize that, well, this is actually an important psychological problem. What is going on in people's brain when they do that? Because this is one of those problems that we solve so effortlessly and unconsciously that it just does not register that we are doing it. And
Yeah, it
so
sounds weird.
the
You have to like make effort to be like, well, it's the growers of the trees. It's like weird to come up with that.
yeah,
Yeah.
I mean, that's why when I sometimes talk about my work, people look at me funny because they're like, why is this even a thing?
Yeah.
But right, I mean, another kind of a classical example of of this kind of situation, this kind of problem, is that suppose that you want to know what started a forest fire. What was the cause? And that you know that, well, there were a lot of dry leaves on the ground and it was very hot on that day. There was a lot of wind. There was a lightning bolt that struck a tree. There was some oxygen in the air and so on and so forth. It seems almost obvious that, well, it was the lightning bolt that was the cause of the forest fire, even though there are many things that also contributed. And so the oxygen was, in a sense, also the cause of the fire, because if we had magically removed the oxygen from the air, then the fire would not have happened. But it feels almost ludicrous to kind of ask the question, why do we think it's the lightning bolt and not the oxygen? It's like, of course, it's not the oxygen. This is an intuition that our brain is given to us in such a vivid way that it doesn't even feel that we had to do any computations in the first place. And I think that that's why people didn't really think a lot about that problem, and a lot of work that went into this. So this is called the problem of causal selection. Sometimes people talk about the problem of causal responsibility and so on and so forth. So a lot of the work on this sprung up from issues in moral psychology. Right? So people say, well, I know sometimes we have an intuition that some people are more morally responsible for a bad outcome. And when we try to analyze this concept of moral responsibility, then we find that, well, causality has a lot to do with it, which is itself its own interesting thing, right? Because you can imagine a thought experiment where I have an intent to do something bad. I want to harm David, and then David just gets harmed in exactly the way that I wanted, but actually there was no causal connection between my intent and his harm. People will not punish me as much because there was no causal connection between the bad intent and the bad outcome. And so this is a bit of a tangent to say that in the process of analyzing how people think about moral responsibility, philosophers and social psychologists and experimental philosophers came to wonder, well, how is it that we attribute causal responsibility in the first place? And so, yeah, I think that is interesting because we had to recognize that there is an information processing to be solved here, but we did not, the field did not really come to it in a very direct way.
So, how do we figure out when someone is morally responsible? I mean, certainly, the causal part of things is relevant, but do we figure it out in the same way that we figure out that the lightning bolt caused the fire, or is there something different going on in the realm of moral responsibility?
Well, maybe it might be useful to talk about the information processing logic of causal responsibility in the first place before we extend it to the realm of moral responsibility. So one sort of obvious idea for how we assign responsibility is that we engage in counterfactual thinking. Right? So the reason that we think that the lightning bolt was the cause of the forest fire is that we imagine a counterfactual possibility where we remove the lightning bolt and we see what happens to the forest fire. Right? And then we say, like, without the lightning bolt, then there's no forest fire. And intuitively, it produces the correct result. But one problem with that is that we are now kind of forced to judge that the presence of oxygen in the air was also a cause of the forest fire, right? Because well, if there was no oxygen, then there was a forest fire. An example that people often use is, so you can have this situation where you ask me to water your plants while you're away on a trip, because I'm the one that's supposed to water it, and I kind of forget, and then your plants wither and die. So you can say, well, my omission from watering the plants was the cause of your plants dying, which seems like a fine thing to say. And this is because if I actually had decided to water your plants, then they would have survived. Right? So in that counterfactual, the outcome has changed. But then you can also say, well, no, I think it's the Pope that caused your plants to die. Because if the Pope had come to your flat and watered your plants, then they would not have died.
Yeah,
Right?
there's
So
a lot of counterfactuals. If you didn't have plants, you wouldn't have killed them. I mean, if there was no water, you wouldn't have killed.
The space of possible counterfactuals that are relevant is just infinite, right?
Yeah.
And so people need to have a way of just focusing on the counterfactuals that are actually relevant to the problem of causal attribution. And so a lot of what is going on is this, that some counterfactual possibilities are just more relevant than others. And there is some work that has looked at what makes a counterfactual relevant for the purpose of causal attribution. And so roughly, a counterfactual is relevant if it was kind of high probability to begin with. Okay, so the Pope coming to your flat and watering your plants was so unlikely that this would happen that this is not a relevant possibility. And in the same way, the absence of oxygen in the air is such a remote possibility that we're not going to consider it. Also, people don't really focus on counterfactual possibilities that deviate too much from what actually happened.
So the idea is that, sorry, like just to make, so like in an alien world where oxygen was variable, but lightning was not, those aliens would think that the oxygen caused the fire.
Yeah, absolutely. And then, I mean, where it gets maybe a little bit more spooky is that kind of social and moral norms also seem to have an influence on what we think, or the relevant counterfactual possibilities. So it might be that, I don't know, I every day, like Dave and I kind of come to water your plants, but you kind of repeatedly ask Dave not to come in. It's kind of like he's not supposed to be here, but Dave comes in anyway. And I'm really the one that's supposed to come in and water your plants. So then if kind of suddenly neither of us come and your plants die, it seems that I'm the person that is responsible for your plants dying because I'm the one that was supposed to be here. And so like the counterfactual possibilities, the counterfactual possibility where I I actually show up at your apartment seems to be the most relevant counterfactual.
Mhm.
And this is something for which I kind of wish there was a strong adaptationist answer for why this should be a functional requirement of causal attribution. But I don't have super well-formed ideas about why this is the case.
Well, wouldn't it be that, I mean, what unpacking relevant, it comes back to interventionism, right? So like if the point is what's the thing that David can do going forward, it's gonna be weird to say, well, Dave, I was wrong. You should have been coming all along. Uh like he has to recalibrate himself and me, but just you, right? So like he asked you to water the plants, but you didn't. He asked me to not be there, but I was there and we didn't water the plants. The most efficient, the biggest bang for your buck causal interventionist thing is to recalibrate how much you are taking into account what he's saying about the
Right.
about that. Like you just failed to do something you heard him say. So that's
Right.
like I mean, it's not
Well, I
exact. I'm
mean,
not. Yeah,
couldn't
yeah.
it just be reframed in terms of the more likely counterfactual being more relevant? Because if you think about people responding to social expectations or me doing what you request of me, like the probability that I will do what you request of me is very high, right? Um, or the probability that I'd forget is also pretty high, right? And so it may be that responding to requests or social expectations is very relevant because the uh, the degree to which we take them into account or not is just at baseline a very high likelihood thing to consider. Is that
Yeah. I think that's one possible explanation. It's a little bit
yeah,
of a deflationary explanation that all
yeah,
people are actually just tracking probability.
yeah.
Um, I think that there is some evidence against this where people have done experiments where they really emphasize, well, no, like the kind of frequency of those things is really the same.
Hmm.
But then you could counter argue that, to what extent do participants actually believe what you're telling them, and maybe they're still um, using those social norms as a cue to probability. That's for sure.
Hmm.
But I'm kind of inclined to believe that there is there is still an effect of kind of social expectations on the relevance of counterfactuals. And one possible explanation to that is what Dave suggested about identifying good points of intervention.
Hmm.
Maybe another possibility is that when we engage in causal attribution, we are trying to communicate things about our beliefs, about our values, about our own model of the world. And so one way that we can communicate what we expect of others is to actually make causal attributions that will contain cues about what we expect them to do.
Yeah. So that would predict, for example, like let's say there's I don't know, we're holding up I'm trying to think of a good example. This is a dumb example, but let's imagine like we're holding up a wall that might fall over. Um and or we need to, right? Like we've noticed this wall we've all worked hard on and we need to, and I tell like 10 people the wall's falling over, it's gonna like cause our it's gonna like it's gonna hurt us in some way, right? And then another 10 people I don't tell. And all else equal, the wall falls over. And then you just say, like, well, who's responsible for the wall falling over? My intuition is it's the 10 people I told. And that's just a readout of like who's more likely to, if I add a little bit of information, or who's easier to convince. Like that's the that's more and more responsibility. So I think it comes back to that's the interventionist account right there, that
Yeah.
that it's going to be easier to intervene if I've already told somebody and there's common knowledge that there's a cost and there's a problem versus I haven't even said anything yet to you. That's enough to tip it towards the first 10 and not the second 10.
Yeah, and it is definitely the case that the counterfactual where those people show up is much more relevant than the counterfactual where it is the 10 people who have not heard the information that show up.
Yeah, I mean, I personally, like, this is my own bias. I don't like it relevance language because I find that obscuring
Yeah,
because I think it's sort of an outcome of the interventionist calculation. It doesn't like the relevance is sort of a placeholder for like this is what you think, not that
yeah.
relevance is calculated and then that's what causes it to be the outcome. It's that it's relevant because it's the outcome calculated based on interventionist logic. I mean, that's my own personal bias, but
Interestingly, the sort of the relevance of something is not there is not always a direct mapping between the relevance of a counterfactual and whether it is selected as the cause, which was like I
Mm.
think one of the most interesting discoveries in this research on causal attribution. And I can first give a like an example of an experiment that shows this, that the most relevant thing is not always what people pick as a causal explanation. And then I can maybe say a few words about my own preferred explanation for this pattern.
mm,
Right? And so you can imagine that there's this person, call them Bob. They're trying to graduate, and they're almost past all the requirements for graduating. They just need um, to pass two different exams in order to graduate. Right? So they need to pass the history exam, which is famously very easy, and they need to pass the math exam, which is famously very hard. Almost everyone fails at the math exam, right? And so they really need to pass both of them in order to graduate. And suppose that Bob he passes the math exam and the history exam, and therefore he graduates. When you tell people that story, they will say, "Well, I think Bob graduated because he passed the math exam." Right? And so here we have a situation where it seems that the most relevant counterfactual is kind of failing the math exam because it was very likely in the first place that he would fail this very difficult exam. And also people think that, yes, it was passing the math exam that was the cause. So here we have an alignment between what counterfactual is relevant and causal attribution. But you can also modify the story in a very slight way, in such a way that actually you will get the reverse pattern. So now if you say, well, and this is Alice, and she also needs to graduate, but Alice will graduate if she passes either the history exam or the math exam. And again, the math exam is the most difficult thing, but she only needs one of them. And then again, Alice passes the math exam and the history exam and she graduates. When you ask participants, uh, why did Alice graduate? They will tell you, well, it is because she passed the history exam. I don't know if you, to what extent you share this intuition, but maybe it was, that's the, she only needed to pass one of these. And since the history exam was the easy one, that's the one that actually explains why she graduated. Um, and in that case, it is still the case that if we think about what is the most relevant counterfactual, the one that is easiest to come to mind in a way, that is the counterfactual where she fails the mathematics exam. Because again, the math exam is super difficult, and so it's quite likely that she would have failed it. But despite the fact that um, the most relevant counterfactual is the one where she fails the math exam, people have this intuition that it was passing the history exam that caused her to graduate. Right?
Mhm.
And really, all that we did is change one word in the story, like
but
Yeah.
there's
just how many events they
yeah,
needed to.
So
but on the
do you
rel
have
yeah, go ahead.
do you have a take on why what explains this? I have intuitions
I,
about what might explain it.
I do, but maybe Dave had a
No, it's
Yeah, sure.
fine. No, 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 no. Go
methodological
ahead. No,
comment.
no, no, no. Yeah.
Okay,
Should I give
I'm
you
interested. Yeah,
what
yeah,
I'm
of course.
guessing
Yeah.
is going on, and you can tell me that I'm wrong? It might be that what we're simulating counterfactually is how likely she would be to study for the history exam versus the math exam. Like whether she would really invest in trying to pass the history
Mm.
exam because that's going to get her the most bang for her buck. And so we're imagining that, and that it would be really unlikely if she invested all of her effort studying for the math exam.
So it's
Um,
interventionist, sort
yeah,
of, again.
yeah, and it's again, yeah, it goes back to this notion of what is the optimal point of intervention.
Yeah.
Um, yeah, I like this explanation. However, I don't think it can explain like all possible cases.
Okay.
So you can run the same version of this experiment where the two events are completely out of your control. So
Hmm.
you have no, in order to, you're playing some sort of casino like chance game, and in order to win the game, you need to kind of draw a ball from an urn, and kind of you're going to draw at random. And so maybe you're going to win the game if you get a green ball from either one of two boxes. In that would be one condition, um, and in the other condition, you win if you get a successful draw from the urn from both boxes. And so in that kind of setup, you still find the same effects. And then since the outcome of a given draw is a random one, you can't really uh, give an explanation in terms of like how much someone's going to prepare.
Hmm. Okay.
If that makes sense.
But isn't it
Yeah.
still intervention in the sense of like what's the outcome that has the biggest bang for the buck? Or like what do you need to what goal do you need
Yeah,
to meet such that
yeah,
like
yeah.
if you were like, well, how is it gonna do if I could manipulate the system, what's the thing I need to do to get the outcome I want?
Yes, that's definitely one explanation, and people have tried to formalize this insight in computational terms, and it explains some of the data, but not all of it. Uh, so,
Yeah.
um, but the most parsimonious explanation that I came up with for that is that um, when people make a causal judgment, they imagine not just one counterfactual possibility, but they simulate many of them. Right?
Hmm.
So they kind of simulate some number of counterfactuals. Um, and each counterfactual is simulated with a probability that is proportional to kind of its what we would call its relevance. So it is simulated in proportion to how to its prior probability, simulated in proportion to how close it was to the actual event, and so on and so forth. And then once you have this collection of different counterfactual possibilities, you can compute the correlation between the cause and the effect across those counterfactuals. Yeah, so if you're trying to think, oh, is it the passing the history exam that caused Alice to win? Then you compute what is the correlation between passing the history exam and Alice graduating in the worlds that you have simulated. And so when you do that, you find that, well, there is in almost all worlds she graduates, right? And she passes the history exam. And it kind of doesn't really matter whether she passes the math exam or not. And so the correlation between passing the history exam and graduating is quite high. And that's why you think that it was passing the history exam that was the cause of her graduating. And now we can apply the same logic to the case of Bob. So just as a reminder, Bob needed to pass both the math exam and the history exam in order to graduate. Like he really had to have both. And so you kind of engage in the same process of simulating counterfactual possibilities. And now you see that, well, there's going to be many worlds in which Bob passes the history exam, but he fails the math exam. And so he graduates. Right? So really the only possible worlds where uh, Bob is going to graduate are the ones where he passes the math exam. So it means that
Hmm.
now you have a high correlation between passing the math exam and graduating. And this then explains why we think that, well, in the case of Bob, it was passing the math exam that caused him to graduate.
Let me make sure. So in other words, it's the crucial difference of all these counterfactuals are run through. It's sort of what's the crucial difference that leads to the outcome desired versus not desired.
Yeah, yes, yes. But this idea of, I think this idea of a crucial difference is a nice intuition for what is going on. Uh, and this kind of process of counterfactual simulation and computing correlation is an explicit information processing description of what is going on.
Right. It's a crucial difference right across those counterfactuals.
Yeah, yeah.
Yeah.
Interesting. Uh, Presumably, these counterfactual simulations are happening unconsciously. It seems like it introspectively when I was thinking about the Bob problem or the math test problem. Like, I didn't have a vivid, simulation in my head where, he passed in this case, he didn't in this case, he graduated in this case. It's just kind of I just had an intuition. So presumably these simulations are happening unconsciously.
Yeah, and I think I assume that yeah, it is the case for most people. I
Yeah.
myself don't really have the phenomenology of running those simulations.
Hmm.
And so from a cognitive perspective, there are two different possible accounts of what is going on. There is an account where we do run those simulations, but it's just implicit and unconscious. There is maybe another account where we don't even need to really engage in simulation. It instead our brain has found a way, kind of a shortcut that allows you to compute what would be the result of those simulations. Kind of maybe as an analogy for what this possibility might look like, you might think about the much simpler process of computing probabilities. And so I might one way that you could compute the probability that a dice is going to come up for is you just simulate many rolls of the dice, and you count up the number of fours, right?
Hmm.
But you don't necessarily have to do that. You can use the laws of probability theory to compute that. And so there might be a way that our brain has also evolved some shortcut way of computing what would be the outcome of such counterfactual simulations.
Would an
Hmm.
example of that just be that like there's a representation of high variability and low variability, for example, like associated with like, doing good in math versus this. And so even just that common sense knowledge about the variability um, curtails some of the needing to run through the simulations.
Yeah, I mean, it might be that if I kind of give you um, like a novel scenario where you have an unfamiliar thing, then your brain needs to engage in simulation. But if I ask you about something that is much more common knowledge, I mean, in the sense that those are familiar things, then you can use a sort of a pre-computed schema for causal assignments.
Yeah, or even just like if you have like imagine like physics is a really good example. Like let's just say
Yeah,
the folk physics system in your head, the physics engine in your head, just calculates based on certain experiences how precarious something is. And then there's principles that then just can get extended automatically to new instances based on the extracted cues. So, like, is a beam precarious, like when it's up straight up and down
mm,
versus like laying on the ground? And in that has been based on past runs of the
yeah,
physics and seeing these things fall. But now there's sort of that gets represented and attributed in new instances without running the simulation. That on its own, if you see a new instance where the counterfactual depends on the likelihood of stability versus falling, that involves no running of
yeah.
of the counterfactuals. It's just that there's already a system there that plugs into one is more likely, one is less likely, and you don't have to run which the counterfactuals. It would be a concrete example of that.
Yeah, yeah, I definitely think that something like that could happen. And I think, yeah, I think it's an example, it's an illustration of the fact that the model itself is really couched at the kind of the David Mars computational level of analysis, where
Right.
like, okay, here is the computation that the system is trying to implement. Um, when it comes to how the
Yeah.
mind is doing that,
Yeah.
concretely, kind of all bets are off
Exactly. Yeah, yeah,
currently.
yeah,
Yeah,
exactly. And
Yeah.
I think intuitions about what's easier and harder are really bad then too, because
yeah.
it's what it feels like to me to do something is not how hard or easy it is for a computational system. Yeah.
Yeah. I mean, because what's interesting to me is that there are cases where this is conscious that I could think of pretty easily. And it seems like when I do have a phenomenology of causal reasoning, it tends to fit your model pretty well. So, like, the example I'm
Yeah.
thinking of is I'm playing chess and I really want to get checkmate. I might actually consciously simulate all the different moves and counter moves. If I do this, you might do this in response. If you do that, I'll do this in response. And I might simulate a bunch of different possibilities. You know, if I move this piece versus this piece, and I might look at the correlation it consciously in my head of moving this piece and checkmate further down the line. And if that correlation is high, like, oh, in all these different simulated possibilities, moving this piece helps me get to checkmate, then I'll
Mhm.
move that piece. So it seems like there are some cases where we are doing this in a full-fledged conscious way. And I'm curious if you have any thoughts about when we would need to do that consciously and when we wouldn't.
Yeah, something that is related to that point is that even though, even if we assume that the system is kind of mostly implicit, um, it's not. I don't want to use the term encapsulated here in Dave's presence because this will
I'll leave. I'll go
but
get a
you can
coffee.
sort
I'll
of,
go get a coffee.
you can definitely like verbally intervene on that system. So people have done this experiment where again you have the case of Alice who needs to graduate, and this time I don't tell you anything about the difficulty of the exams. I just tell you there's the history exam and the math exam, right? And
Mhm.
I tell you, okay, she passes the math exam, she passes the history exam, and I tell you, well, just try to imagine, what would have happened if she had failed the math exam. Kind of
Mhm.
try to really simulate the counterfactual. And then after you have done that, I ask you, well, what do you think was the cause of her passing? And then people will say, oh, this was the history exam. Right? And so you kind of sort of can artificially push people to simulate one counterfactual more.
Mhm.
And then this will have an effect on their causal attribution.
Mhm.
So you can sort of, even if the process is implicit, you can sort of use explicit communication in order to influence what people are going to do.
Hmm. That's fascinating.
And I think then the other part of your question is, when are you going to engage in sort of more conscious simulation?
Mhm.
Um, I think that, and at least one part of the answer is that if you are in a novel situation, maybe this is the first time that you've been playing this particular um, kind of chess game. I guess you were never in that position before, then you need to engage in explicit simulation.
Mhm.
But maybe if this is a situation that you're very familiar with, then all the computation has just been done and you can rely on schemas that have been pre-computed on the basis of your past experience.
Interesting. So maybe
Yeah,
like the opening moves are just going to be rote, but like the end game,
yeah, yeah,
that's where my conscious reasoning might kick in.
yeah, yeah. And
Hmm.
I think that to a large extent, the people who develop AI systems that play chess or Go, they have
Hmm.
this kind of hybrid architecture where they will rely a lot on those kinds of um, cached, pre-computed um, sort of calculations of what is the value of a particular move. And then they
Hmm.
will combine this with more explicit simulations. Um, and it's quite likely that the human brain is designed along more or less the same principles.
Interesting.
um, let's talk about theory of mind.
Yes.
I mean, talking about nebulous, hard to understand, obtuse stuff. Uh, I have a very soft spot in my heart for theory of mind. Theory of mind, like the ability to attribute mental states. Mental states are just like causation, as we talked about, like where in some sense they do exist, right? Like in the sense of it's a convention of like, of course, I have a desire and a belief, and um, but there's another sense in which they're placeholders for common outcomes in the world. So it's very confusing and weird and abstract too. So, um, so where does theory of mind come in? And is essentialism part of it, or is that a separate part? Is because in addition to causation, you've tackled theory of mind and essentialism. So that's like the trifecta of abstraction. What is up with theory of mind and essentialism, and are they related?
Yeah. Well, I think that the nice thing is that we could do like a 2 hour discussion on each.
Exactly.
So maybe, yeah,
Get
which is also the
comfortable.
bad
Get comfortable.
the bad news. But maybe for the sake of kind of for the sake of tractability, I'll focus on theory of mind for now.
Sure.
So theory of mind is, yeah, I mean, as you said, it's quite interesting because there's that's a lot of abstraction. That we can't really see someone's desires or someone's beliefs. Yet we have to attribute beliefs and desires and so on and so forth to other people in order to even start understanding their behavior. If I were to just try to model you in physical terms, then this would be very difficult. I mean, I would predict maybe you're going to say to stay roughly at the same place over time, that there will be some sort of spatial temporal continuity to your behavior, but that's roughly how far I'm going to go. Whereas when I attribute to you mental states, then the richness of my explanation of your behavior is going to be much more effective. Right. And so this is something that has been of quite a lot of interest to psychologists, because obviously we want to know what is the functional logic of this system that has been so important. Evolutionarily, this is something that social cognition is, especially in a species like ours, it is super important. If you cannot predict the behavior of other people, and if you cannot exert some degree of influence on them, then you are not going to go very far. Right. And so a lot of research and theory of mind has looked at our ability to attribute beliefs, and there are good reasons to that, right? Because in order to really predict someone's behavior, you need to engage in what people call a meta-representation. A meta-representation is just a fancy term to say a representation of a representation. Okay, and it's because if I represent the representations that are inside your mind, then I will know how you behave. And a standard test for whether someone has meta-representations is whether they are able to imagine that someone might represent the world in a different way than your own. Okay? So, and to give a simple example, there is a mug on the table on my office, and I assume you can see it, and so I can represent that maybe I can represent that Dave has a representation of the fact that there is a mug on the table. But to really have a handle on, to really be able to prove that you have a representation, I need to show that you are able to represent the world as being different from it actually is. And so maybe you might have, I might have a sophisticated hologram of a table, of a mug on the table instead of an actual mug. If that is the case, I know that there is, in fact, no mug on the table. But I know that you believe that there is a mug on the table. And so a lot of research and theory of mind has been looking at this ability to attribute false beliefs to others. And in some of my recent work, I've been trying to see how maybe how we can think about theory of mind that involves representations that are not as demanding as that.
What makes it demanding?
So in the case of like representing that, maybe you think that there is a mug on the table, whereas
yeah, like let's say you move the mug and I didn't know that. Like I just have a false belief. So like you told me, you showed me the mugs on the table, it's out of frame. You are like a false belief, naughty character. You move the mug. I didn't know it. So now you know where the mug is, but I don't. So I have a false belief. Yeah.
Yeah. Intuitively, it's not necessarily demanding, but I mean, if you think about the logic of meta representation, it's if you really take it to the extreme, then it means that when I represent your mind, then I will construct a whole model of your model of the mind, right? And that's obviously that's a lot to represent. So I need to represent like how I think the world is, and then I need to have another representation that is basically the world as I think Dave sees it. Right? And so if you take on to the extreme, it's really this idea of meta representation really involves the commitment that I'm going to have one model of the world for each person that I'm trying to interact with.
So just
That
to
makes
make
sense.
sure I understand,
Yeah.
you're arguing against a sort of an argument, which is the way that we represent other people's mental states is we create an additional model of an entire other human brain and what it currently is representing in addition to our own, and that we multiply that every time for new states of the world and for new agents, and that sort of naive model is unlikely to be true.
Yes, yeah,
Yeah.
that's a good summary. And I don't think that anyone is really claiming that we do that, right? But if you kind of look at this claim that theory of mind involves meta-representation and that you run all the way with it, then it seems to be the logical consequence.
Yeah. And so
yeah,
what's your claim that is instead of that claim,
yeah.
what is your argument? What's going on? Yeah.
Right. And so an interesting question is indeed now, what are ways that the system could actually work and not completely run out of memory every time you're trying to predict someone's behavior. And here, the idea that we have been putting forward is that you don't always need meta-representation. And in fact, in most cases, you don't actually need it. So in the case where I'm not playing any tricks on you and there is actually a mug on my table, and you see the mug, and now you know that there is a mug on the table, then I don't need to attribute to you necessarily the meta representation that there is a mug on the table, that kind of a belief that there is a mug on the table. Instead, I can just note that, well, you know that there is a mug on the table. And so what this does is that I have a physical description, and I have my own physical model of the world. So in my physical model of the world, there is a mug on the table. And then in addition to that, I just add a very simple binary representation that, oh, Dave knows this fact, right? So now instead of having to duplicate my own model of the world in sort of the meta representation that I attribute to you, I can just have this one binary, one like on or off tag about whether you know this.
And
Interesting.
what that on-off tag means is all the inferences and consequences that I have for the mug, the other agent has as well. I'm not
Yes,
saying that
yeah,
that's the full model, because of course it's not right, because like I might see it from a different angle and you would need that additional. But just to be clear, like what it means is that um, there's no difference between all the things that follow about the mug for you are applied to me, but they don't have to get applied to me. It's just that there's representation of everything that is represented in me about the mug also applies to this other agent.
yes, exactly.
Yeah. So it's
So
like
Like
one piece of information instead
yeah,
of duplicating a brain.
right.
Yeah.
In the
yes,
same
exactly.
way that, we scan the physical environment and we tag physical objects with various properties, we might say this, coffee cup tag belongs to Dave, contains hot liquid,
Yeah.
is, this shade of blue or whatever, um, uh, you know, uh, whatever. And in addition to that, another tag is Dave knows it. And we just, oh, or Dave knows it's there. And we just have that tag to,
Yeah.
everything we know, um, Dave also knows.
Yeah.
Right.
Yeah, that's it's such a great description of the proposal. Yeah, it's just
Yeah.
one more feature of the
Yeah.
object.
Great.
Hmm.
Yeah, and so I mean, this was just an idea. This is not an idea that actually came from us. This existed in the literature, but this had been proposed as just like one possibility for how a theory of mind might work. And what we did actually in our project was to try to take a more adaptationist stance towards this proposal. And we said, well, can we actually formalize what is the adaptive problem here? Right? And we started with this fact that, well, we obviously we need to predict and explain the behavior of others, but we also have a constraint on our information processing capacity. Like we don't have infinite computation, we don't have infinite memory, and so on and so forth. And so the design of our theory of mind system needs to somehow trade off between those two different considerations. We want to have a lot of predictive power while at the same time like not run out of computation every time we interact with someone. And this is this idea that computation is a constraint is really salient in the context of theory of mind, where it's very easy to run out of memory when you're predicting the behavior of an entity that is as complex or even more complex than you are. And so once you set up this optimization problem where you try to trade off between those two different things, the nice thing is that you can solve for it. You can ask, well, what would be the optimal cognitive strategy for solving that problem? And we did that by setting up a toy model. So we had sort of a simple agent-based model, and in that agent-based model, there's one agent that is basically doing a series of very simple theory of mind tasks. So there's like a false belief task. There's a task where you need to predict what someone who has knowledge of a fact is going to do, and so on and so forth. And this you can sort of then optimize the cognitive strategy that this agent is going to use. And when we did that, we find that indeed, if your agent is sufficiently constrained in terms of its information processing capacities, then it will use a strategy that is very similar to the one that I just described, where it will kind of abandon any pretension of creating meta representations. Instead, it will just have its own physical description of the world, and then it will add a kind of a binary tag about whether like, this fact is known or not known by the other person.
Is one way to think about it then that so like I'm not a I don't know, I'm not like left-handed. So like let's say there's a right-handed guitar and a left-handed guitar, and I reach for the right-handed guitar, and then I see somebody else making that same decision, but they're left-handed, they reach for the left-handed guitar. My model of predicting what they would have done is wrong when I just use what I would do. Right. So then I have to say, I have to have an entry for what's the minimal extra information I need to add to still use me as the machine for predicting behavior, but then change one variable to generate the right prediction. Is one idea that like all these kinds of things of like what a false belief actually is, or what a motivation is, or a personality variable, they're all just sort of settings on what's the minimal thing I need to add to my own inference engine about what I would do next to then just predict the behavior of others. That sort of all these representations that we think of are just sort of just slight tweaks to this otherwise very complicated system that we don't have to repeat and duplicate. So it's just that for Tadeg and for David, I just have my own it's like an equalizer, and it's sort of like I have the presets for David such that when I think of David or I see David, I can pull those up and I know my own self-simulation system. I need to add these 20 or 10,000 tweaks to all those little inference engines, but that's only little 10,000 bits, right? It's just small tweaks to the big machine. Is that a fair, I mean, I realize it's sort of abstraction, but is that a fair way to characterize the bigger picture here?
I think it's what you are describing is a more general extension of the general principle that we should, like, to the extent that we can, the system should be minimizing the computational complexity by using all tricks that it has available. But the core insight behind our model is that even before we are trying to predict the behavior of others, we have our own model of the physical world, because it is super useful. It's very useful to know like what the world looks like. And the nice thing about other people is that they also live in the same world. Okay, and so by virtue of the fact that you're living in the same world, you will end up creating representations that are actually quite similar. And so this is a kind of a nice fact about the problem of social prediction, is that you're predicting the behavior of agents that also live in the same world. And so it means that to a large extent, you can use your own understanding of what the world looks like in order to predict their behavior.
It also means
And
you
so,
can know when an
yeah,
error occurs, right? Because that's one of the other
yeah,
problems is like a lot of the machine learning, the trick is to know when an error occurs, and that's the discrepancy between what they do, which you
yeah,
have
yeah.
data for, and what you would do, which you also have data for.
Yes, yes. And so really, like really from this point of view, yes, the main challenge is to compute what are those aspects of the world as I represent it that other people also are aware of.
Hmm.
And this is so I mean, an interesting thing about that is that this model, even though it is relatively simple, it makes quite interesting predictions. Because you can look at for a particular setting of the parameters, you can look at the optimal cognitive strategy that an agent comes up with. And you can see, well, to what extent does this actually describe the behavior of actual organisms. And here, a particularly interesting case is when we look at non-human primates. Okay, because non-human primates, they are much more constrained in their information processing capacities as we are. And maybe they don't have to use theory of mind to such an extent that we do, because the sort of social demands of their ecology are not as strong. And so you can sort of set up an agent that has not a lot of information processing capacity for the purpose of theory of mind. Which is kind of, you can think of it as a simulated monkey. And then you can look at the strategy that this simulated agent is using. And one prediction that follows from that is that they will behave in a certain way in tasks that are a little bit like a false belief task, except that you have changed one thing. So this task is called the accidental true belief task. So this is a task where so suppose I hide an apple in front of Dave. So like you're aware that I'm hiding an apple in this one box. And then you go away, right? And while you're away, I will remove the apple from that box. But then I put it back in the same box. Okay. So what it means is that you have a belief that the apple is in that box, right? But there's a sense in which your belief is kind of lucky, like because it was just a chance event that I put it back in the same box.
Or
And so,
to make it, let's say, you
yeah,
remove it from the box and put it on the windowsill, and then a bird magically flies in and picks it up and puts it back in the box.
yes,
Right. Or a tree, it falls a
So
tree,
that's,
Yeah,
another
if a
tree.
tree,
Yeah, it's under an
the wind
apple
blows
tree.
and
Yeah,
blows it into
exactly.
the So
yeah,
so you just
A
really
forest
got lucky.
fire, a forest fire that was caused by a lightning
yes.
strike.
Yeah.
And so in that situation, like something surprising happened, which was that kind of the simulated agent sort of stops making any prediction. It was like, oh, like the situation is too complicated for me. I'm just going to throw my hands up in the air, and basically, I'm going to predict that you will look that Dave will look in any of the boxes. I'm not going to make any bet about where Dave is going to look. And it turns out that this is exactly how monkeys behave if you give them that kind of task. And so it seems, and that there's a lot of similar experiments that are done on non-human primates, where they do things that look a little bit weird, but that are quite well predicted by this kind of version of the model where you assume that the agent does not have a lot of information processing capacity.
Interesting. Well, fascinating stuff. I feel like I could keep picking your brain on this for hours, but we are approaching the end of our time. And is there any topic that you wish we would have talked about that we should have asked you about? Anything that
Oh yeah, I think another thing on which we could have spent a lot of time is this concept of intentional action that is also
okay.
related to theory of mind, but it's its own
Oh
its
yeah.
own thing.
Well, here's what I'd like to ask. How did you discover? We haven't done origin stories in a while. How did you come across EvPsych?
Yeah, so I've always been quite interested in the general question of how the mind works, but I didn't really know it back then when I was in high school. And so I decided to, because I was also interested in history, and so I decided to do political science as a major. And that's when, in the process of majoring in political science, I read this book by David Hume.
And back to
kind of
back to Edinburgh. Full circle. Yeah.
And so I was kind of blown away by the fact that this guy was asking those deep questions about the mind. And it's made me realize, well, this is actually something that I find super interesting. And so I ended up double majoring in philosophy. And this is what led me to do then a master's in cognitive science in Lyon. And the master's was interesting. There was a lot of interesting stuff about behavioral neuroscience, cognitive psychology, and so on and so forth. But while taking those courses, I always had a nagging feeling that there was a set of important questions that were not asked. And then, of course, like now I know that I was internally complaining about the fact that there was not much of an evolutionary perspective being offered. And then it came time to find an internship, like a research internship for my master. And there was this new researcher at the university called Pascal Boyer. So I reached out to him and like, oh, can I attend your lab meeting? And then during the lab meeting, he's sort of like laid out the perspective for what his research over the next few years what was going to be. And I had this kind of this click of, oh, this is what I want to do. And a year later, I was at UCSB working with John and Ida.
That's fantastic. So wait, Pascal was where?
So he was in Lyon at the time
because he had
gotten a grant to stay there for a few years.
Fantastic. Yeah, we have to have Pascal on.
Oh, I can't believe you haven't had him.
I know, right? Yes. Yeah. Well, Tadeg, thank you so much for being on. My brain is full.
I know, yeah. I've exhausted the computational capacity in my head.
But yeah, thank you very much for having me.
Yeah, this is great.
It was our pleasure. Yeah, this is a really fun conversation. I learned a lot.
David, what causes a good podcast?
Well, hold on. Let me run through all the counterfactual worlds in my head.
Copper wires.
Yes, oxygen in the atmosphere is definitely a critical component to a good podcast. If there was no oxygen, then we wouldn't be alive. Yeah. So leave us a kind review and talk about
all the
things role of oxygen.
All the things that could have gone wrong such that you wouldn't have discovered this podcast.
Yeah, that's a great content for your kind review. You can also visit us on Patreon, and that might have a causal impact on the continuation of this podcast. Maybe we can afford some.
Very fateful. This is very. It feels very.
Well, we're just giving you ways you can intervene on the world.
Yeah, exactly.
You have free will to do any of these things.
Yeah, but there's weird unintended consequences to things too. So be careful what you do.
That's true.
I'll see you next week, David.
Yep, sounds good.
All right. Well, see you, everybody. Okay.
See ya.